Hello everyone. Today I'm going to explain the topic operation on arithmetic and logic units. Arithmetic and logic unit. An arithmetic logic unit is a fundamental component of a computer's central processing unit that performs arithmetic operations such as addition, subtraction, and logical operations such as AND, OR, and XOR. It serves as the core computational unit in a digital system enabling data manipulation and decision making. The architecture of arithmetic logic unit consists of three components. Those are arithmetic unit, logic unit, and control signals. Arithmetic unit performs mathematical operations like addition, subtraction, multiplication, and division, whereas logic unit performs operations such as AND, OR, XOR, and NOT essential for decision making. And control unit it specifies operations by selecting and activating the required functionality through control lines. So, arithmetic unit addition, it performs binary addition, including carry propagation for multi-bit numbers. So, as you can see in example, 1010 plus 0110 is there. When we add both bits, we get 10000 with carry. And in subtraction, while subtracting two bits, we will do two's complement of second bit and then add to the first bit. As you can see in example 1010 minus 0110 is there. When we want to subtract these 0110 with 1010, first we should do 2's complement of 0110. So we can do 2's complement by first take a number 0110. So we can do 2's complement by inverting this by making 0 as 1 and 1 as 0. So here 0110 is there. So we can make it 1001 and then add 1 to it. So we get 01 carry 101. So we get 1010 as you can see here. Then add it to the first number 1010. So we'll get answer as 10100. So second one is logic unit. The logic unit of an ALU performs bitwise operation essential for processing logic decisions. These operations include AND, OR, XOR, and NOT. In AND operation, it produces a 1 only if both input bits are 1. And in OR operation, it produces 1 if either of the input is 1. So in XOR, it produces 1 if both bits are different, and it produces 0 if both bits are same. And as you know, not is a inverter operator. It inverts 0 to 1 and 1 to 0. Next is logic gate. Boolean logic is represented using logic symbols. Logic gates use Boolean logic to take one or more input binary and produces a single binary output. So here first one is AND gate. AND gate, both inputs must be true for a true output. It gives 0 when one of the input is 0. So it acts as a multiplication operation. As you can see here, when both the inputs are 0, it will give 0. When any one of the input is 0, then also it will give output as 0. When both the inputs are 1, it gives output as 1. So in OR gate, only one needs to be true for a true output. So in OR gate, any one of the input is 1, then we'll get output as 1. See here 0, 0, it will be output as 0. When one input is 0 and one input is 1, we'll get output as 1. Same here. And at last, when both the inputs are 1, we'll get output as 1. In XOR gate, only one input can be true for a true output. As you know, in XOR gate, when both the inputs are same, we'll get output as 0. And when both the inputs are different, we'll get output as 1. Next is NOT gate. Basically, it is an inverter which produces, when we put input as 0, it gives output 1. And when input is 1, we'll get output as 0. Next, control signal. ALU control signals play a vital role in directing the ALU's functionality. Control lines specify which arithmetic or logic operations the ALU should perform based on the input instructions. The next second one is multiplexing logic. Selects the correct output from multiple operations, ensuring the desired result is routed for further processing. Basically, multiplexing logic is like multiplexer. Next, shift and rotate operations are essential for data manipulation in digital system. Shift operations move bits left or right in a binary number. Logical shift fills empty positions with zero, whereas arithmetic shift preserves the sign bit for signed numbers. And second one is rotate operations. Circulate bits left or right with the bits shifted out, re-entering from the opposite end. These operations are crucial in tasks like encoding, multiplication, division, and optimizing data storage. So next one is ALU operation. The instructions are designed to perform arithmetic operations such as addition, subtraction, multiplication, and division, as well as logical operations such as AND or AND not operations. In first example, add R0, R1. The mathematical representation of this instruction is as follows. Here R adds the content of in this mathematical representation. Here adds the contents of R0 with the content of R1, then stores in result as R1. And in example 2, sub R0 comma R1. The mathematical representation of this instruction is as follows. Here is the mathematical representation which subtracts the content of R0 from the content of R1, and result is placed in R1. So next third example, and R0 comma R1. It logically multiplies the content of R0 with the content of R1, and result is stored in R1 only. Here is the mathematical representation. At last example, not R0. It performs the function of complementation. So these were the ALU operations. So thank you.